This is Eureka Math. We are in Module 5 and today is Lesson 11. And our objective is to find the area of rectangles with mixed by mixed and fraction by fraction side lengths by tiling. So what they mean by mixed and fraction by fraction is if we have a length and a width, which is our formula for finding area, what they're saying is that this could be 1 1/2 and 1 1/4, and we have to multiply those mixed fractions, okay? And fraction by fraction, which could be, again, area equals length times width, perhaps 3/4 by 1/2, okay? So we're multiplying fractions today. We've done that a lot when we were doing fractions 2 units ago. Or was that last unit? I can't remember. So today, just keep that in mind, multiplying fractions, you know how to do that. So I'm actually going to forward ahead here because they're giving us the dimensions here in our debrief. So I want to do that before we get to our Lesson 11 problem set. So please write your name on it. Okay. Draw the rectangle and your tiling, write the dimensions and the units you counted in the blanks. Then use multiplication to confirm your area. So I'm going to give you the dimensions here. So we're going to do a length equals 4 1/2, and our width equals 2 1/2, okay? So first I need to draw my rectangle and use tiling. So if my length is 4 1/2, and my width is 2 1/2. I'm going to have this be my width and this be my length. So 2 1/2 would be 1, 2 1/2. Okay, and then length is going to be 1, 2, 3, 4, and then this is a half. Okay, so 1, 2, 3, 4, and that's an L. Okay, so here's my tiles. So 1 times 1 is 1. 1 times 1 is 1, and this is a half. So a half times 1 is a half. Okay, do you remember how we did that? Then 1 times 1 is 1. 1 times 1 is 1. 1/2 times 1 is 1/2. 1 times 1 is 1. 1 times 1 is 1. So I'm doing length times width, right? Half times 1 is a half. So length times width, and I'm doing it for each little square. Width of 1 times length of 1 is 1. 1 times 1 is 1. Now I've got 1/2 times 1 is 1/2. Now be careful. This isn't 1. So 1 times 1/2 is 1/2. And 1 times 1/2 is 1/2. And now I've got 1/2 times 1/2 equals 1/4. Do you remember that? 1/2 times 1/2. And we just multiply straight across, and we would get 1/4 here. Now I can add them all up, and I'll find my area, okay? So the dimensions and the units, and what units were they using? Does it say? It just says units, okay. So I have 1, 2, 3, 4, 5, 6, 7, 8, plus a half is 9, plus another half is 10, plus another, 2 halves is 9, 2 halves is 10, 2 halves is 11, and a fourth. So 11 and 1/4. Let me just count that. 1, 2, 3, 4, 5, 6, 7, 8, and then these two together would be 9. These two together, 10. These two together, 11, and then 1/4 left over. Okay, so units squared. So the length is 4 1/2 units long, and the width is 2 1/2 units wide. So we drew the rectangle, we wrote the dimensions, okay, and the units, which was just units, we didn't use inches or centimeters, and we counted the blanks, right? Then we use multiplication to confirm the area. So let's do that. We're going to just use some multiplication to confirm. And I have 2 ways I can do that. I can use my distributive rule, right? So it's going to be 4.5 length times 2.5 width. And I can either distribute, right, and do 4 times 2 plus 1/2 times 2 plus 2 times 1/2 plus 1/2 times 1/2, which I'm going to switch colors one more time, which would be 4 times 2 and then 4 times 1/2. Oh, I did make a mistake. Look at that. This is why I'm glad I checked my work. I hope you got that. 4 times 1/2. Okay, and then, so 4 times 2, 4 times 1/2, and then 1/2 times 2, which is here, and 1/2 times 1/4, which is there. Okay, now using my distributive property, which I just did, I multiplied everything times everything. Now I can just add that up. I've got 8, and 4 times 1/2 is 2, and 2 times 1/2 is 1, and 1/2 and 1/2 equals 1/4. So 8, 9, 10, 11 and 1/4. Okay, that was using distributive property. Now, you have another option. You could, and I'm pause here and write this down if you want to write it down. I'm about to erase it. Okay. Instead of using the distributive property, you could turn those into improper fractions and multiply across. Some people like that better. Some people like to use the distributive property a little bit better. It is up to you. I can show you the distributive property right here on this too, because we had 4 and 1 and 2 and 1/4, which is exactly what we got in our problem. I don't know if you realize that. I'll show you in the next one. Now, if I want to use improper fractions, I have to turn 4.5 into 9/2. And so that's my length. And my width would be 5/2. Okay. And if I multiply that together, I would get 45/4, which would equal, wait a minute, is that right? Seems like I did something wrong there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 1/4. But that's not 11 and 1/4, is it? 45 over 4. 45, that's why. Sorry. 2 mistakes in a row. I hope you're catching on there. Okay, so 45 divided by 4 would be 11, with 1 left over, 1/4. Okay, math facts, got to check those math facts. So if you want to just turn that into an improper fraction, you can do it that way. Or if you want to use the distributive property like I showed you right before, you can do it that way too. And basically, this is showing the distributive property because here we've got 2 times 4, which is what I showed you, right? 2 times 4, which was that. And then 2 times 1/2, and then 1/2 times 4, and then 1/2 times 1/2, right? I'll show you that one on the next one. Okay, so write this down if you want to write it down. I'm going to erase it. You do need to show your work. It should be on your paper, but I need enough space to do rectangle B. So I'm going to erase this, and I hope you wrote that down. You can always go back in the video and write it down again. Okay, now let's pick a completely different color, orange. And I'm going to go back here and just see what they're doing. 3 3/4 and 1 3/4. So we have 3 3/4 and 1 3/4. Is that right? Let me double check. 3 3/4 and 1 3/4. Good. Okay, so if this is my length and this is my width and I'm trying to find area, I'm going to multiply across. But I need to show you with a rectangle and tiling because that's what it asked us to do. So 1 and 3/4. So here's 1 3/4. Okay, and then 3 3/4. So 1, 2, 3, and then this last one is 3/4. So 1, 2, 3 3/4. Now I can figure out what the volume is by multiplying length times width. So length times width is 1, length times width is 1, length times width is 1. Length times width here is 1 times 3/4, so that's 3/4. Okay. Now 3/4 times 1 is 3/4, and 3/4, and 3/4, and 3/4 times 3/4 is going to be 9/16 up here. Okay, 9/16. So, what's my volume? I've got 1, 2, 3, and 3/4 plus 3/4 plus 3/4 plus 3/4, because there's 4 of those, right? 1, 2, 3, 4. That would be 3, 6, 9, 12 fourths, which equals 3. Okay, so I've got 1, 2, 3, and then I've got 4, 5, 6, and my leftover is 9/16. Okay, can I simplify that anymore? No. Okay, 3 and 9/16. So long is 3 3/4, and width is 1 3/4, and my volume is 3 and 9/18. 1, 2, 3. I'm sorry. Terrible. I hope you're catching all these mistakes today. Why am I making? You know what it was? It's Independence Day. It's been a long weekend. Okay. 3 3/4, but I forgot to add these. 1, 2, 3. That's 6 3/4. Okay. Hope you caught that. All right, now I'm going to show you mathematically instead of using my tiling to show you how I can solve this. And switch to green, I think. Now, if I were using the distributive property, I would do 3 times 1. Look at this. I would do 3 times 1. And then I would do 3 times 3/4, which would be these 3 times 3/4, right? Then I would use this 1 here, right? And multiply that by 3/4 here. And then finally, so that was that one times this one. And then finally, I would do 3/4 times 3/4 here. Oh, my handwriting has gotten too messy here. So let me rewrite that in a little bit more, maybe smaller handwriting so you can see it. I'm just going to rewrite it, so don't worry. Okay, so 3 times 1 plus 3 times 3/4 plus 3/4 times 1 plus 3/4 times 3/4. So that's 3 times 1, and then 3 times 3/4, and then 3/4 times 1, and then 3/4 times 3/4. Do you see how I just split that into 4 different sections there to add it up? So I've got 3, 1, 2, 3, plus 9/4, that's right here, plus, right here, 3/4, plus 3/4 times 3/4, 9/16. And then I add those all together, and I have to turn this into mixed fraction, so that would be 2 1/4 plus 3/4 plus 9/16 plus 3, which equals 3, 4, 5, and then 1/4 plus 3/4 is 6, and 9/16, sorry. Okay, 3 and 9/16 units squared. That was using the distributive property. Now, if I want to use my improper fractions, and at this point, if you want to use improper fractions, that's fine. If you want to use the distributive property, that's fine too, as long as you show your work, okay? In the future, there will be different reasons for using different things. For example, the distributive property is really nice if you don't know the value of one of your sides. But we're not quite there yet, so that's probably more of a 6th grade thing. Okay, so 3 3/4 would be 12, 13, 14, 15/4 times 4, 5, 6, 7/4. And that would give us 16ths on the bottom. 15 times 7, this is why I don't like to do it in such big numbers, would be 35, 7, 8, 9, 10, 105 16ths, and then we would have to take that 105 and divide it by 16 to see what we get there, which would be 1, 2, 3, 4, 5, 6, 7, 8, no, it's got to be, well, 6. 6 times 6 is 36, with the 3, 6 is 9, and we're left over with 9, which would be 9/16. Okay, so I don't know if you prefer this way or the distributive property. Up to you. All right, triangle C. Triangle C is 1 1/2 times 3/4. Okay, 1 1/2 times 3/4. So here we've got a mixed fraction and just a fraction. And there's, what am I doing? Okay, 1 1/2. There's 1 1/2. And here, this whole thing is just 3/4. I could even draw in the rest, which would be a whole. And in each one of these little things, I'm going to multiply. So 3/4 times 1 is 3/4. And 3/4 times 1/2 is 3/8. Okay. So there I've shown my length times my width. There's my length, there's my width. And together they show the area. So how long is it? 1 1/2. How wide is it? 3/4. Now, what is the area? All I need to do is add 3/4 plus 3/8. And that also means that I need to make a common denominator. Remember, fractions, when you're adding, they need to be common denominators. We're not multiplying. So we're going to multiply this times 2 and get 8. And we're going to multiply this times 2 and get 6. So now it's 6/8 plus 3/8, which I can add together because they have the same common denominator, which is 9/8. And that's an improper fraction, so let's turn it back into a mixed fraction and get 1 1/8 units squared. Okay, there we did it. We showed it with the tiling. Let's erase this. Now, you shouldn't erase it. You should keep it on your screen or on your paper. I just do not have enough space, so I'm going to erase it so I can show you. And now I'm going to multiply 1 1/2 times 3/4. And with my distributive property, that means that I need to multiply 1 times 3/4 and 1/2 times 3/4. So 1 times 3/4 plus 1/2 times 3/4, which is exactly what we did here. 1 times 3/4, right? And then 1/2 times 3/4. You see how the tiling matches this? It's kind of nice. 3/4 plus 3/8 equals, and then we turn that into 6/8 equals 9/8 equals 1 1/8 squared. Okay, so that was the distributive property. Or, of course, if you want to turn that 1 1/2 into an improper fraction, we can multiply it that way as well. This one, it's such a small numbers that it's not too difficult, but we can do it that way now. Okay, so 1 1/2 would turn into 3/2 times 3/4, which would equal 9/8, which equals 1 1/8 units squared. Cool. All right, number 4. And our units for number 4 are 3/4 and 1/2. Okay, I'm going to write that up here. 3/4 times 1/2. So this is all smaller than 1. So if my length is 3/4 and my height is 1/2, I've got 3/4 and 1/2. And I can show you what a hole would look like. If this is 1/2, it would be here. And if this is 3/4, it would be about there. Okay. So this is 1/4 and this is 1/2, and together they make 1 and 1. And the area of this whole thing is 1. So if we're finding the area of this section, it's going to be less than 1, isn't it? If it's more than 1, we've got a problem. Okay, so this section has got to be less than 1. So I'm going to erase all that because we don't need it. And the only thing we have to do is multiply 1/2 times 3/4, which equals 3/8 and 3/8. And I bet I could show you this would be 3/8, and that would be 1/8, and that would be 1/8. And then 3 plus 3 is 6, plus 1 is 7, plus 1 is 8. 8/8 is a whole. But we are only finding the area of the small red section. So our rectangle D is 3/4 units long and 1/2 units wide, and the area is 3/8 units and a half. And there's no distributive property there. We're just multiplying. So. Okay, let's move on. Number 5. Colleen and Caroline each built a rectangle out of square tiles placed in 3 rows of 5. So square tiles, if they're square, that means that their length and their width are equal. Their length equals their width, right? Because it's square. All right, so each built a rectangle out of square tiles placed in 3 rows of 5. I'm going to go ahead and draw that here. 3 rows of 5. 3 rows. Okay, 4. I'm just going to draw one more in there. 5. So we have 1, 2, 3 rows and 1, 2, 3, 4, 5 columns, or our length is 5 and our width is 3. Colleen used tiles that measured 1 2/3 centimeters in length. So each of these is 1 2/3. So because they're squares, remember, their length and their width are the same, so this is 1 2/3. Okay, so we've got 1 2/3 for each of those, and there's 5 of them. We have 1 2/3 for each of those, and there are 3 of them. Caroline used tiles that measured, okay, so this is Colleen's, okay, and Caroline used tiles that measured 3 1/3 centimeters in length. So hers is going to be much bigger. Oh, I'm sorry, I forgot to shut off my phone. So this one belongs to Colleen. And we'll make another one for Caroline. And hers is also 3 by 5, but each of hers are a little bit bigger. Hers are 3 3/4 or 3 1/3. So each of these is 3 1/3 and 3 1/3, and there are 5 of them. Okay, and this way there are 3 of them. Okay, draw the girls' rectangles and label the lengths and widths of each. Oh, see, we drew them before they even asked us to. But they want to know what the length and the width are of each one. So we're going to have to find that. So Colleen, right? Ooh, I spelled her name wrong. Poor Colleen, I'm sorry. Colleen's is the length and the width. So her length is 1 2/3 times 3, because there's 1, 2, 3 of them. And that's the length. And then the width is going to be 1 2/3 times 5, because there's 5 of those. Okay, so if this is length and this is width, let's figure that out. So, distributive property here. 1 times 3 is 3. And 2/3 times 3 is 6/3, which actually equals 2, which equals 5. So her length, or this side, is worth 5. And okay, 1 times 5 is 5, plus 2/3 times 5 is 10/3, which means her width is 1, 2, 5, 6, 7, 8, and 1/3, right? 5 plus 10/3 equals 8 1/3. Okay, so that is 8 1/3. Now, for Caroline's, she has still times 3, but each of her squares is 3 1/3 times 3. That's the length. And her width is times 5. It's 3 1/3 times 5. So that's her width. Okay, so 3 times 3 is 9. And 1/3 times 3 is 1, because it's 3/3. So her length is 10. And the width would be 3 times 5 is 15. And 1/3 times 5 is 5/3, which equals 16 2/3. So this number down here would be 16 2/3. Okay. All right. Now, what are the areas of the rectangles in square centimeters? So first we have to find the area of Colleen's. Oop, I'm going to go back to blue because we're using blue for Colleen. And we said 5 was the length, so length times width. 5 was the length. Oh. And the width is 8 1/3. Okay, so here I've got 5 and here I've got 8 1/3. Now I just need to multiply that and I'll have the area. So 5 times 8 is 40. And 5 times 1/3 is 5/3, which equals 41 2/3. And what are these measurements in? They are in centimeters. Centimeters cubed. Okay. And now I'll do Colleen's. Colleen, we said her length was 10. So area equals length times width. We said that that was 10 times, and the width was 16 2/3. So 10 times 16 is 160. And 10 times 2/3 is 20/3, which would be 6 and 2 left over. So that would be 166 and 2/3 centimeters cubed. Compare the areas of the triangle. Okay, well, 441 and 2/3 centimeters cubed is way smaller than 166 and 2/3 centimeters cubed. Okay. I don't know if they want us to do more than that or not there for where it says compare. Oh no, that's exactly what they did. Okay. And a square. Okay, so this is number 6. So we're done with Colleen and Caroline. And here we can just write in Caroline's. What are we calling this? Caroline's rectangle, because she built a rectangle. Rectangle is much bigger than Colleen's rectangle. All right, period. Okay, number 6. A square has a perimeter, so length times width. And perimeter, we find perimeter by either 2 times length plus 2 times width, or if you just want to write it with addition, you could say perimeter equals length plus width plus width. Now, it's a square, so the length and the width are the same. So we can also say perimeter perimeter of a square, it has to be a square, equals 4 times width, because length and width equal each other, right? Okay, now that we have the formula, what is the area of the square? Now, the area we know is 51 inches, and we know that we know the perimeter equals 51 inches. So what are we going to have to do? We're going to have to divide that by 4 in order to find out what each side is, right? Because there's 4 sides. So 51 divided by 4 would be 12 and 3/4, is that right? 4 times 12 is 48. And 4 times 3/4 would be 12/4 would be 49, 50, 51. Okay, so each side is 12 3/4 inches. Do you see how I got that? I'm going to erase this and show you one more time. And I can check my work. Okay, so if I know that the perimeter here is 51 inches, and I know that my square, or my perimeter is 4 times W, in order to find W, I just can divide this by 4 and divide that by 4. And that's going to give me 51 divided by 4 equals W, right? So I just moved it up here. And then, what did I just say that was? 48 and 3/4 equals, no, not 48, 12. 12 3/4 equals one side, the width. And the width and the length are the same, so this is 12 3/4, and this is 12 3/4, and this is 12 3/4, and this is 12 3/4. This is the math I remember from when I was a kid that I really liked. Okay, now that I know what each side equals, because they only gave us the perimeter and we had to figure out what each side was, so we divided this by 4. What is the area of the square? Now we have to do area equals length times width, okay? And the length and the width are the same, so it's 12 3/4 times 12 3/4. And we have 2 chances here. We can do our distributive property, or we can do our improper fraction. So let's go ahead and do improper fraction. So 4 times 12 is 48, 49, 50, 51. Look, it's already there. 51 fourths times, it's the same, 51 fourths. Okay, do I really want to multiply 51 times 51? Okay, well, let's do that. 51 times 51 is 1 times 1 is 1, 1 times 5 is 5, and then drop my 0, 5 times 1 is 5, 5 times 5 is 25, and my answer is 2,601 over 4 times 4 is 16. Okay, so now I have to divide 2,601 by 16. So that'll go in there one time. 16, that will give me 10 left over. Drop the 0, that's 100. 16 will go into 100. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 times, I'm guessing. If I'm wrong, I'll find out real soon. 7 times 6 is 42. 4, 7, 8, 9, 10, 11. Oh, sure did. Let's try 6. 6 times 6 is 36. With the 3 over here. 6 times 1 is 6. 7, 8, 9. And my leftover is 4 with the 1. And 16 goes into 41. Twice. So 16 times 2 is 18. Carry the 1, and that's 38. And then I've got 3 left over. So 162 and 3/16 is my area. Area equals 162 and 3/16. And it's inches cubed. Let's try that with a distributive property, just to try it, just to make sure. Okay, I'm going to erase all of this when we found the perimeter. I'm going to erase that. You can keep it on your paper, please. I just need more paper. And $12 3/4 times 12 3/4. So 12 times 12 plus 3/4 times 12 plus 12 times 3/4 plus 3/4 times 3/4. I'm just checking my work because using improper fractions is not my favorite. So, okay, 12 times 12 is 144. 3/4 times 12 is 9 plus 9. And here at the end I have 9/16. Maybe I made a mistake. So 18, 19, 20, 21, 22, 1, it's 9, 10, 11, 12, 13, 14, 9, 10. Oh, I don't know what I'm doing. And this says 9/12, which is not what I got over here. I made a mistake somewhere. I'm glad I checked my work. 9/12 would be 3/4, which is squared. So that is where I made my mistake right there. It's not 3/16. But I've already erased my work, so I can't go back and find out what I did wrong. Okay, good idea to check your work, everyone. This is also why I like the distributive property a little bit better too. Okay. All right. Sorry, I seem like I'm taking up a lot of your time today. So here's your homework, and they've given you the dimensions, so we don't need to go in the book and look for them. And then your exit ticket, that is 12. And we are on 11. So your exit ticket, this is from last week, 11. To find the area, Andrea tiled a rectangle and sketched her answer. Sketch Andrea's rectangle and find the area. Show your multiplication work. Okay, easy. Yep, just an area problem. Okay, but show your work and your multiplying fractions. And if you have any questions, let me know. Have a great day.